Hello. In the last tutorial, we looked at how to write to and read from an Avro file. In this tutorial, let's look at how to read from and write to a parquet file. A parquet is a columnar file format, which means all the related columns will be stored sequentially. So the first step is in the pom.xml file, you need to bring in the parquet library. So as shown here below, the parquet version we are using is 1.50 for the Cloudera, and here there will be a parquet entry, so we are using com.twitter, and the artifact ID is parquet-avro, and the version here is defined via the variable here, the property, and the property at the top is 1.50, and the provided says it's only required for compiling. If we package this Spark job and deploy it to Cloudera and run it as a Spark submit, this library will be available in the Cloudera runtime environment. So that's why it means provided. So firstly, let's look at how we can write to a parquet format on our hdfs. So this is very similar to Avro, but there are quite a few differences, and these differences are marked as a comment, so you can compare them with the Avro. So if I double click on here, so parquet also require a schema, and we can use the same schema as the Avro one. So here we are calling it a simple Spark simple, and we're running in a local mode, so I can run it within Eclipse itself. I don't have to package it and run it on a yarn cluster or whatever. Then it's using the serializer, so we are using cryo serializer, which is more efficient than the default Java serializer. So if you don't specify this, it'll use the Java's default serializer. And then we are creating a Java Spark context and then generic record. And this generic record will be very similar to the one we created for the Avro. So if I click the control button and then there will be an underline here, click on the open implementation. So we are creating a generic record, Avro record that put order ID and the order name. So once you have created a list of generic records, then we are going to create an RDD. So create an RDD, you call the parallelized methods and pass this list of generic records, and the coalesce one is to create one partition. So sometimes when you have large number of records, there will be multiple partitions and it will be creating multiple part files, but if we coalesce to one, there will be only one part file. The next step is from RDD, resilient distributed data sets, we need to create a pair RDD. So we're creating a Java pair RDD. The only difference here is the first change from Avro to Parquet. In the comment it says is when we did the Avro one, the pair RDD means you have a tuple 2 of key value pairs, but we set the key in the Avro, but we set the value to void. In this case, the key is void, but the value is a generic record. So you're passing a null and an X here. So X if you hover over, which is a generic record. So you'll get a Java pair RDD with the void being the key and generic record being the value. Then in order to be able to connect to hdfs, we need to set this property. So fs.default fs is equal to quickstart.cloudera, which is the name node's host name, and 8020 is the port number. And you can go to this cosite.xml file and under this folder, etc. Hadoop conf. So you can go to a terminal window, go to that, and you can look for this fs.default fs value and whatever the value it displays, and that will be the path it connects to for the name node. You can also go to the Cloudera manager and look for the name node's URL, which will be quickstart.cloudera. Then this is the path we are going to write it to. So before we wrote it to user Cloudera Avro orders, now we are going to call it Parquet orders. This can be anything. Then you're creating a job instance. Then this is another difference. You can see the second change is you got to use the Parquet output format, and the right set the write support, and also the Avro parquet format, and you have to set the schema. Then once you have done that, we call the same save as new Hadoop file method, and we are using the coiless one because we want a single partition, and key class is void, and the value class is generic data, and the output format we are going to write it, that's a change, is parquet output format, and the job configuration, and you start writing it. So here also the schema, which is very similar to what we did for the Avro. So I'm going to go into Hue, Hadoop User Experience, and delete the parquet file that is already there. So I go into parquet, and it writes under orders. I'm going to go into the orders, and then I'm going to say move to trash, delete this, and then go within Eclipse and then run this as a Java job because it got a main method. So I'm going to go into the com.mytutorial, and there should be a thing called write to parquet. So write as parquet to hdfs Java. So I'm going to right click on it and say run as Java application, and keep an eye on the console to see if there are any errors. So I haven't stopped any of the Cloudera services, so all the services should be running. If any one of them, if hdfs is down or whatever, then you will get an error. So when you run the job, you can see it's going through some initialization, Spark initialization process, and then it'll start writing to hdfs, and then there'll be a Spark shutdown process. So it looks like it has finished running now. So if I scroll through, we're not printing any outputs here, so it won't display anything. So the only way to find out is go to Hue and see if it has written to hdfs. So here I have to refresh this because I deleted that earlier. So if I click on the refresh button, and you can see a folder called orders would have been created. So we are saying write to orders, so that's our destination. The target folder, you can see here it's hard coded to orders. So if I go back to Hues, see it has created orders folder, and under that, depending on how many partitions are there, so in this case we call as to 1, there could be multiple files under this. So in this case, you can see there's success, that means 0 bytes, it says the job has succeeded. There's some metadata, common metadata. These are all parquet related metadata, and you can see a part file called r00 parquet. So if you have another file, it will be part-r0001 and so on. So now if I click on this, the Cloudera will display it as a text file. Actually, the parquet is a binary file. This is just a text representation of actual parquet file. You got order ID 1, 2, 3, John, 4, 5, 6, Peter, 7, 8, 9, Samuel, and so on. But if you click on the view as binary, this will be the native format the parquet file will be in. So when you say view as text file, Cloudera is doing some special conversion to show it in a text representation. So now we have written to a parquet file. So next thing we will see how we can read from one. So if we go to read from a parquet file, so I double click on it, so you can see spark conf read from an Avro file, then set local. So local asterisk means the multiple thing means there will be multiple threads. So you can say local 1 instead of asterisk, local 2 or whatever, there will be 2 threads and so on. Because it's a local mode, they'll be running in the same JVM. Similar thing, set up the serializer, cryo serializer, the Java context, and provide the HDFS path where we're going to read from. So in this case, this is the name node 8020 user Cloudera parquet orders is our base directory where all the part files are stored. So this is the entry point is the orders, which is under parquet, and that's shown here. So which is the parquet orders. And then we create a job configuration, and before you created parquet output format to write to, now you're using parquet input format and setting the read support. Before we set the write support on the parquet output format, now we are setting the read support on the parquet input format. and we will be getting a Java pair RDD when we read. We are using this new Hadoop file, new API Hadoop file method, and it takes the input format class before it took the output format class, is the input format class, and the key is void obviously because we write it with the value, and the value is a generic record. So what you get is a pair RDD of key being void and the value being a generic record. Then you're passing the job configuration. This is where you set the Avro support, set the read support for the parquet. And then on the pair RDD we get the values because keys will be always void or null, and for each we are printing the system.out.println. So this should output the values that it reads. So to run this, I'm going to click on this and read as parquet file format from hdfs via Spark. So because this is a Spark job, right click on it and I'm going to say run as Java application. So it's going to go through the initialization process, and then it should be printing out on this console the values that it read. So it has finished running. So if I look through the logs for any errors, no errors, and you can see what it has outputs. Order ID 123, John, 456, Peter, 789, Samuel, which is what in the hdfs. So that's all for reading and writing from a parquet file. In the next tutorial we'll see how we can put a hive over parquet, similar to what we did for the Avro. We use the Avro tools, and here also we can use the Avro tools to get the schema. The schema will be very similar to Avro, but we can also then download parquet tools that gives us different utilities to deal with parquet files. So in the next tutorial we'll look at how we can download parquet files and use it. When you use a quick start, we had Avro tools out of the box, but the parquet tools doesn't come out of the box. We need to download and install it. It's a matter of downloading a jar file and running it. We'll look at that, and how to create a parquet file is slightly different from creating a hive over Avro. So we will be creating a hive table over a parquet. There's two-step process involved. We'll look at that in the next tutorial.